In this video, we're going to talk about how to calculate the variance and the standard deviation of basically a list of numbers. The variance, or rather the sample variance, is denoted by the symbol s squared. S stands for standard deviation. And both of these terms, they measure how far out or how spread out the data is from the center. So let me give you an example. Let's say if we have the first list of numbers, 6, 7, 8, 9, 10. And let's compare it to another list of numbers, 4, 6, 8, 10, and 12. So which list has a higher standard deviation? Is it the first one on the top or the second one on the bottom? It's going to be the second one. Notice that the numbers, they're more spread out from the mean. There's more variation. As you can see, the first number, 10, is 2 units away from the mean, 8. The second number, 12, is 4 units away. So I'm going to put plus 2, plus 4, minus 2, minus 4. So there's more deviations from the mean. Therefore, the standard deviation and the variance will be higher for the second list. Looking at the first list, the deviations from the mean will be plus 1, plus 2 on the right side. On the left side, minus 1, minus 2. So the standard deviation and the variance tells us the spread of the data, like how far the data is from the mean. So let's talk about how to calculate the variance and the standard deviation for the first list of numbers that we had. So we're going to make a table. X is going to represent the data values, and then X bar will represent the mean of that data, and then X minus X bar, so the data values minus the mean, that's going to tell us the deviations. And then in the next column, we're going to have the square of the deviations. So the numbers are 6, 7, 8, 9, and 10. Now what we're going to do is we're going to take the sum of the first column. The reason for that is it's going to help us to calculate the mean. The mean is going to be the sum of the data values divided by n. So if we add 6, 7, 8, 9, and 10, that's going to give us 40. So that's the sum. The mean is going to be 40 divided by n. Now what is n? Looking at our list of numbers, we have 5 numbers in this list. So therefore n is 5. 40 divided by 5 is 8. So the mean is going to be 8, which we'll put in the second column. Now let's calculate the deviations. So this is going to be x minus x bar. So here it's going to be 6 minus 8, which is negative 2. And then 7 minus 8, which is negative 1. 8 minus 8 is 0. 9 minus 8 is positive 1. 10 minus 8, positive 2. Now if we add up the deviations, negative 2, negative 1, 1, and 2, it's going to add up to 0. Now the next thing we need to do is square the deviations. Negative 2 squared is 4. If you write it like this, this is negative 2 times negative 2. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Our next step is to add up the deviations. 4 plus 1 plus 1 plus 4 adds up to 10. Now you need to know what this number represents. So that number is basically the sum of the square of the deviations. We're going to use that to calculate the variance and the standard deviation. Now the variance, represented by s squared, this is the sample variance. It's going to be the sum of the deviation squared divided by n minus 1. So we already know what this value is based on what we see here. That's 10. N is 5. There's 5 numbers in our list. And 5 minus 1 is 4. 10 divided by 4 is 2.5. So this is the sample variance of the data. So I'm going to write that here. S squared is 2.5. So that's how you can calculate the sample variance, or the variance of a sample. Now let's calculate the standard deviation. Here's the formula for the standard deviation. It's the square root of the sum of the square of the deviations divided by n minus 1. So the standard deviation is basically the square root of the variance, which we already have here. So it's going to be the square root of 2.5, which is approximately about 1.581. So now you know how to calculate the standard deviation and the variance of a sample. Now it's your turn. So using the second list of numbers that we had, 4, 6, 8, 10, and 12, go ahead and pause the video and calculate the sample variance and the sample standard deviation. Go ahead and try it. So let's construct the table first. So we have x, x bar, and x minus x bar, the deviations, and then the square of the deviations. So our x values are 4, 6, 8, 10, and 12. Now let's calculate the sum of the first column. So 4 plus 6 plus 8 plus 10 plus 12, that's going to be 40. So now let's calculate the mean. The mean is going to be the sum divided by n. The sum is still 40, and we still have 5 numbers in the list. So once again, the mean is 8. Now let's calculate the deviations. 4 minus 8 is negative 4. 6 minus 8 is negative 2. 8 minus 8 is 0. 10 minus 8 is positive 2. 12 minus 8 is 14. 12 minus 8 is 4. Now, if we add up this column, the sum of the deviations should always be 0. Next, let's calculate the square of the deviations. Negative 4 squared is 16. Negative 2 squared is 4. 2 squared is 4, and 4 squared is 16. Now, if we take the sum of those values, 16 plus 4 is 20. 4 plus 16 is also 20. 20 plus 20 is 40. So at this point, we have everything we need. We have the sum of the square of the deviations. So now let's calculate the variance. So the variance for this sample is going to be the sum of the square of the deviations divided by n minus 1. So the sum of the square of the deviations, we see that is 40. N is still 5, and 5 minus 1 is 4. So it's going to be 40 divided by 4, which is 10. So the variance is 10. Now our next step is to calculate the standard deviation, which is simply the square root of the variance. So it's going to be the square root of 10, which is approximately 3.16. It's like 3.162277, and those numbers go on. But I'm going to round it to 3.16. And so that's a very simple way in which you can calculate the standard deviation and the variance. Now we're going to try another example, a harder example, one with more numbers, but particularly numbers that repeat. And so we're going to modify the table that we've been using to fit the problem that we need to do. So those are the list of numbers. If you think you know what to do, feel free to pause the video and try it. Now the old method can work, but you'll need a longer table to do this. However, if you incorporate frequency, you don't need to use all 12 of these values. So the height of the table will be shorter. The first column is going to be x. The second column will be the same. That's going to be the mean. The third column will be the deviations. And the fourth column is going to be the square of the deviations, just like before. But now we're going to add two additional columns. One will be the frequency, and the last column will be the frequency times the square of the deviations. Now, by the way, we're going to check all of our answers using Excel, so stay tuned for that. So the lowest number that we have is 5, and then the next number is 7, and then 8, 9, and 12. So we have 5 different numbers. Now, in the previous examples, what we would do is take the sum of the x values. In this case, that's going to be 5 plus 7 plus 8 plus 9 plus 12. That's 41. But this is not the sum of these data values because some of these numbers repeat. And so we need to incorporate the frequency. So what is the frequency for the first number, 5? Notice that we have 4 of that number. There's 4 5s in the list. So the frequency is 4. How many 7s do we have? We have 1, 2, 3 7s. Now for the next number, 8, there's only 2 8s. So the frequency is going to be 2. And then for 9, we only have 1 9. And the last number, 12, there's 2 12s. Now, if we take the sum of this column, that's going to be meaningful. That's going to tell us how many data values we have in our list. 4 plus 3 plus 2 plus 1 plus 2, that's 12. So that tells us that there's a total of 12 numbers in this list. Now our next step is to calculate the mean. And what we're going to do for that is we're going to take the sum divided by n. So to find the sum, we need to multiply the data values by their frequencies. So we have 5 4s, and then we have 3 7s, and then we have 2 8s, 1 9, and 2 12s. So let me change this and write sum. So 5 times 4 is 20, plus 7 times 3, which is 21, plus 8 times 2, that's 16, plus 9, plus 12 times 2. So the sum of these values is 90. So the mean is going to be the sum divided by n, where n is 12. So it's 90 divided by 12, which will give us this number, 7.5. So now that we have the mean, we can now calculate the deviations. Five minus 7.5 is negative 2.5. 7 minus 7.5 is negative 0.5. And then 8 minus 7.5, that's 0.5. The next one is going to be 1.5. And then 12 minus 7.5 is 4.5. Now, if we add this column, if we add negative 2.5, negative 0.5, and so forth, we're not going to get 0, as we did in the last two examples. And the reason for this is you need to incorporate the frequency. If you multiply the deviations by the frequency and then add up the values, then you'll get 0. So now let's calculate the square of the deviations. Negative 2.5 squared, that's going to be positive 6.25. 0.5 squared is going to be 0.25. And then 1.5 squared is 2.25. And 4.5 squared, that's going to be 20.25. So now we need to work on the last column. We need to multiply the frequency by the square of the deviations. 6.25 times 4 is 25. 0.25 times 3 is 0.75. 0.25 times 2, 0.5. The next one is 2.25. And then if we multiply those two, that's going to be 40.5. Now, we need to take the sum of that column of data. And so that's going to give us 69. So we're going to use this to calculate the variance and the standard deviation. The variance is going to be the sum of all the deviations squared divided by n minus 1, as before. Now, it's important to recognize that this value is not the sum of the deviations we see here. We need to incorporate the frequency if we're going to get the answer right. So it represents 69. So the variance is going to be 69 divided by n minus 1, and n is 12. So 12 minus 1 is 11. 69 divided by 11 is 6.27, but the 27 part is repeated. So this is the variance of the data that we see here. Now, to calculate the standard deviation, we're going to take the square root of that number. And so the standard deviation is going to be approximately 2.5045, but we'll round that to 5. So that's how you can calculate the variance and standard deviation if you have a long list of numbers where some of the numbers repeat. Now we're going to talk about how to get our answers using Excel. So we have the 3 lists of data that we covered in this video. So let's calculate the variance for the first list of data. So what we're going to do is highlight cell B15, type in equal var, VAR, and then there's .p and .s. .p is the population variance, .s is the sample variance, which is what we're going to use. Type in parentheses, highlight the list of data, close parentheses, and as you can see, this is the answer that we got for the first list of data, 2.5. Now for the standard deviation, type in equal ST DEV, and then .s for sample standard deviation. Then open up the first parenthesis, highlight the data, close the second parenthesis. And so you can see we got the number that we had before, 1.581. Now for the second list of data, let's repeat the process. Equal var.s, and then highlight the list of data. And then equal stdev.s, and then highlight that data. So as we said before, the second list had more variation. Notice that the numbers, they differ by 2. Here the numbers differ by 1. And so because list 2 has a higher deviation, it has a higher standard deviation. The data values are further apart from the mean. Now we could do the same thing for list 3. So let's calculate the variance. And so we got 6.27 repeating. And now let's calculate the standard deviation, which is what we had earlier, 2.505 if you round it. And so now you know how to calculate the standard deviation and the variance using Excel.